What is up, everybody? Welcome on into the Mastering the Exposure Triangle lesson. We are going to be doing two different things here. We're going to walk you through some slides to kind of illustrate things, to teach you a little bit more of the theory behind the exposure triangle and how it works. And then we're going to do sort of a live demo with Andrew, where we're going to set up a little mini scene and just kind of show you how these things work in live view, so we can kind of see how all of these settings interact with one another. We have three key settings when we're thinking about photography. We have shutter speed, aperture, and ISO. Each of these things can do two different things. One will increase or decrease the exposure or the brightness, and then each of them has a secondary function as well. So for shutter speed, it will have more or less motion blur. For aperture, it will have more or less depth of field. That is the amount of stuff that is in focus. And for ISO, it will have more or less noise. And let's go into diving into each of these in a little bit further. Let's first start with aperture. So aperture is represented by the size of the iris on your lens. So this is named by f-stops, and sort of conversely, this might be a little bit confusing. A smaller aperture is actually a higher f-stop number, and that is actually a more closed iris. So for example, we'll see from this illustration here that f16 is a small aperture, meaning the opening is very small, but that is actually a high number, and the iris is more closed. Conversely, a larger aperture, such as f2.8 or f1.4, that is actually a lower f-stop number, so a lower number, but that is actually more open. And the aperture, as I mentioned, determines how blurry or in focus your subject is. So the lower the number, the more blurry and out of focus things are, the shallower the depth of field is. And what that means is there is a small plane in which everything that is within that plane will be in focus, and everything that is out of that plane will be out of focus. So let's just kind of take you and me as an example. Right now, my eye or my face is the focusing plane, and it's a pretty shallow focusing plane because we're at f2.8 at the moment, and we'll show that more with Andrew in just a second. Let's take a look at some examples of small and large aperture in photography. So we have small aperture, again, that is a higher f number, so between like f9 and f22. That is a large focusing plane, meaning everything is in focus. And with that, that means that there is a very low and limited amount of light let in. It sort of makes sense, right? If the iris is very closed, there's not a lot of light that is able to get in. And so what this does as well is it has very minimal or very low amount of bokeh. So that's the blurriness that is behind. And then if we take a look at a larger aperture, such as f1.4 to f4, that is a very shallow focusing plane that is letting a lot of light in because the iris is very wide open, and you'll have bokeh for days. So this is much more common for portraits, for example. Now let's move on to shutter speed. So shutter speed represents the amount of time that your shutter is open. It can be labeled in seconds, anywhere from 1/8000th of a second to 30 seconds. Now with a longer shutter speed, such as 15 seconds, for example, there is a ton of light that is let in because the shutter is opening and allowing light to hit the sensor for a very long time. And with that, we'll get a lot of blurry motion. So anything that is moving while the shutter is open will be blurred out. Conversely, if we have a short shutter speed, such as 1/1000th of a second, that means it is only open for 1/1000th of a second. That means that there is minimal light that is let in, and everything is frozen in motion because things can't move very far in 1/1000th of a second. So the faster your shutter is, the more in focus it will be. And then the slower the shutter is, the more kind of blurry it will be. Focus is not actually the right term there, it's just blurriness. So it doesn't really matter. The focusing distance, that's all kind of set to the aperture. And then another good rule of thumb for setting your shutter speed, the best kind of handheld setting, so without using a tripod, you should do 1 divided by your focal length. So if you're at 24 millimeters, for example, you could sometimes get away with around 1/24 or 1/30th of a second. That's kind of a rough rule as you get a little bit higher up. So like you're at a focal length of 200, you don't want to really get below 1/200, for example. Otherwise, things are going to get a little bit shaky. Let's take examples of some fast shutter speed. So we have our buddy Colin here doing a handstand. So obviously this has to be done pretty quickly because he's only going to be able to hold that handstand for a short amount of time. So we want to do a very fast shutter to freeze the motion and we'll be firing off a ton of shots to make sure we can get one shot in which he's kind of nice and perfectly frozen here. We'll have a minimal amount of light let in, so we'll have to compensate with other things. It's great for moving subjects, and it's great for handheld shots. Conversely, we have a slow shutter here, so great for waterfalls, for example, and any time that we're using a tripod. So this allows us to blur the motion as it's moving across. So you'll notice that things that are not moving, such as the kind of rocks in here, these are not moving, so those are nice and sharp. But the things that are moving, such as the water, is blurred out. This is, again, great for waterfalls and any time that you would need a tripod. So you can kind of compensate for the slow shutter by using a tripod. Next, let's talk about ISO. So ISO represents the sensor's sensitivity to light. It is kind of labeled in round numbers, usually from 100 to 16,000 or more. That sort of depends on how kind of good your camera is at processing low light. The amount of ISO can also influence how grainy or noisy your image is. So you'll notice that as you start to bump up your ISO, your shot will get a lot grainier and kind of less high quality, if you will. So we ideally want to keep it as low as possible while still being able to maintain our shot. So a low ISO, however, will be less bright, will have lower noise. A high ISO will be more bright and have a lot of noise. And let's take a look at some examples of low and high ISO. So this shot during the day, we have a ton of light to work with, so we don't need to have our ISO super high. Best for daylight, it's well lit scenes. So this is somewhere in the 100 to 400 range. And then for high ISO, as I mentioned, astrophotography is great for bumping up your high ISO. It's going to introduce a lot of noise, so you have to be very careful with this. And really, this is kind of one area where the quality of your camera will really start to show. If you are using a kind of starter beginner camera, you'll notice that its ability to handle these high ISO numbers is pretty difficult. Okay, now let's take a step back and let's talk about stops. So I don't mean stop like a stoplight or a stop sign. I mean stops as it refers to light. So there is a notion called a stop. A stop of light refers to the doubling or halving of the amount of light that it takes to make up an exposure. So if we add a stop of light, it will actually double the exposure and brighten the image. Conversely, if we have the exposure, this will take away one stop of light and will darken the exposure. So we can add or take away a stop of light by adjusting the aperture, shutter speed, or ISO. So each of those has these steps that allow us to increase or decrease by one stop. So let's take a kind of quick example here. So as I mentioned, this becomes a triangle. So we can increase our ISO by one stops from 100 to 200. And then we could so that makes the whole image brighter. So to compensate, if we want to keep the same neutral exposure, we would then either decrease our shutter speed or decrease our aperture. So let's take a look at this in another example. So you'll have a light meter within your camera. It will look something like this. Different cameras look a little bit different, but it will generally look something like this. Your camera's light meter will kind of help you to check your exposure. So you can adjust your aperture, ISO, or shutter, and you'll see that there's this kind of meter marker here that will move left or right. So as it moves left, you're underexposing your image, and as you move right, it is starting to overexpose your image. So in order to maintain the exposure, you'll have to adjust each of these settings. So let's look at an example here. Let's assume that this setup gave us a proper exposure. We had an aperture of f4, we're at 1/125 shutter, and then we had our ISO set to 200. And you'll notice here that there are these kind of larger markers. Each of these larger markers is one stop. So even though there are numbers in between, so for example, we have f2.8, and then your camera will likely be able to go to f3.2. That is not a full stop. That's actually a third of a stop. Yeah, third of a stop. So to get one full stop, you'd go to f4. So if we were to change, for example, we increase the opening of the iris by one full stop from f4 to f2.8, that would then overexpose our image by one full stop. So in order to compensate for that, to get back to neutral, what we could do is we could either increase our shutter to 250, so that's one full stop on that one. That would then return us to proper exposure, or conversely, we could decrease our ISO to 100. So we could decrease this. So as we move this way on shutter, it gets darker. As we move this way on ISO, it gets darker. And as we move this way from left to right on aperture, it gets darker. So we can play with these in a triangle to kind of adjust the total proper exposure. Okay, so that's enough of the graphs and theory and things of that nature. What we're going to do now is Andrew is going to show you a quick little scene that we've set up and just kind of walk you through a live demo so you can really see how these things interact and how it changes the look of the image.